Hi everybody. Whoops, that didn't work. This is Mr. Folly, and welcome to Podcast 1.1. Hey, we're starting out on a happy note. We're going to define chemistry. We're going to define matter. We're going to describe the steps of the scientific method. You've been doing this for years and years. We're going to define hypothesis and state that a hypothesis is testable. What is meant by a controlled experiment? Look at all this junk we have to do. It seems kind of long. Let's try and get going so we can see what it really looks like. Distinguish between the terms observation and interpretation. First day of class. Ooh, the boogeyman. Distinguish between qualitative and quantitative, which is kind of straightforward. And theory and law, which you may think are the same, but surprise, they're not. All right, chemistry is. So chemistry, the definition, is the study of matter and the changes that take place in matter. This is a cool looking car. It is matter, not chemistry. This is smoke. It's chemistry. This is a smokestack. Not chemistry. I keep calling it chemistry. This is matter. So we study cars. Cool. We study burning. Perhaps more cool. We study explosions. Perhaps even more cool. We make weird glow-in-the-dark stuff. Perhaps even more cool. So we basically study stuff. So we study matter and the changes that take place in matter. How can I make parts of a mountain turn into that car? Matter. Anything that has mass and takes up space, which is what I was confusing with before. Anything that has mass and takes up space, it needs to have both of those. So this is pretty much everything except for ideas and energy. Gases matter because it does have mass. Notice here's a deflated balloon. Here's an inflated balloon, and look, it weighs more on my 35-cent ghetto scale. Okay, so that's one of the tricky ones to go through there. Gases matter. Scientific methods. One of my professors gets mad that people even say scientific method and gets mad. It's the way scientists collect data and figure things out. So you get a question, you figure out how to answer it, you gather some data, you say your answer, and then you check it, basically. So it can be ask a question, do background research, construct a hypothesis. So it can be a bunch of different ways. The reason why I say there's more than one is, let me make sure on the next slide. The reason why I say there's more than one is a lot of these things have experiments where it's like, okay, I'm going to give my dog 30 sugar cubes and 30 salt cubes and 30 rat poison cubes and see what happens. And that's a controlled experiment. But if you're an astronomer, you have a cool job. And you're not going to be able to say, oh, let's put Mercury behind Uranus and see if it spins around differently. You can't do that. But they still do science. The key to a research question is the hypothesis. Hypothesis must be testable. So it's a testable prediction. You've probably heard of neutrinos, which you don't need to know anything about. You probably haven't heard of neutrinos when I'm saying you have lives. Neutrinos were something that some scientists believed were there, but they said they were undetectable. Well, you can't have a hypothesis that something is undetectable. Okay, so one hypothesis would be the car won't run because the battery's dead. You could test that, right? Replace the battery and see if it runs. The car won't run because evil spirits have taken over. How do you test for evil spirits? I don't know. I don't think you can. Experiments should have a control. So this is a definition of a control. A control is the comparison group to see the effect of what you're examining. So does LT water make you sick? It's the beginning of the year. The pipes haven't been run for a while. The water runs out red. Blood. Okay. 100 kids drink water fountain water. 100 kids drink tap water brought from home. What's the control group? Now, is it possible that some kids here would get sick and some kids here would get sick? Yeah. So what would happen if 5 kids got sick drinking LT's water and 5 kids got sick drinking the tap water? That doesn't support it. Okay. The control group would be the tap water group. Okay. Ding. Observation, we did this first day. Directly detected by your senses. Now, any senses. Senses, not just your eyes. So it can be smell, it can be taste, but don't taste in the lab. It's dangerous. Let's see, there's 5 of these things. Could be touch, sight, smell, taste, touch. Oh, what's the other one? Oh, man, why can't I think of my 5th sense? Hearing. Duh. Sorry. Interpretation is what you think the observation means. So oftentimes you have the word because or the word so, and then I'll go, oh, duh, I may. Interpretation. So examples. Mr. Foley's voice sounds familiar. That would be an observation. Mr. Foley's voice sounds like Buzz Lightyear. Not everyone says that. That's an interpretation. I think I sound a little more like Little Wayne myself. That animal has stripes. Observation. You can directly see it. That metal is rusting. Now this one you may think is an observation, but it's an interpretation because the observation would be it's turning red, right? Or it's crumbly. Those would be the observations that would get you that interpretation. That is gold. It's an interpretation. Your observation would be yellow, like old yeller there, and shiny. You are ugly, like your dog. That's an interpretation. Somebody thinks you're beautiful, maybe your mother. Both observation and interpretations can grow up. Okay. A theory is an interpretation that is well supported. Well supported. That's like saying Bill Gates makes a nice salary. He gets bajillions of dollars. Well supported and generally accepted by the scientific community. Theories can change, by the way. Theories can change. People used to think the sun revolved around the earth. That was a theory. Lamarck's giraffe neck thing. That was a theory. We originally thought if you stretch out, you pass it on. Snape is a bad guy. That was a theory. Oh, Snape is a good guy. Oh, I just ruined all of the Harry Potter books for you. A law is a series of observations repeated so many times in so many ways. Notice the series of observations repeated so many times in so many ways it's accepted as true. So like the law of gravity, it's just an observation. You don't explain it. So, oh, look, I have a remote control. Oh, it fell down. Here's my pen. Oh, it fell down. This is my, oh, look, things fall down. That's the law of gravity. It's just an observation. Why does it happen? I don't know. Okay. There are two types of observations. Qualitative just describes without a number or a unit. It's weird to define something by what it's not. Describes without a number or unit. Quantitative describes with a number and, you need both, a unit. So if I said, what is your best quality? Hardly anybody says, I'm 6 feet tall. Your best quality tends to not have a number, right? Without a number or unit. What's your best quality? You're funny, you're nice. If you're sad, I'm punctual. Right? That's your best quality. I've never had a tardy in high school. That's your best quality. I'm punctual. Way to go. But no one says what's your best quantity, except for girls. Girls, what's this guy's best quantity? He's got dollar bills. How many? He's got millions of dollar bills. And of course, I just made it sound like girls are bad. Guys, you're the same way. You grubby little people. So to review, I observed there are many definitions which I should have written down. Hey, observe with my senses. Should have written it down. Hypothesis must be testable, much like what is on this podcast. Theories cannot turn into laws, and laws can't turn into theories. Now notice this is something new on the podcast. This is new. This is something that will probably be on the pod quiz that you're going to take when you do this. Okay? So I hope you enjoyed it, and I will say this to you. Toodles.